What if gravity, one of the fundamental forces that shapes our universe, wasn't fundamental at all, but instead emerged from deeper principles rather than being an intrinsic property of nature? This is the central idea behind emergent gravity, a theory that challenges what we thought we knew about how the universe works. The concept behind emergent gravity. Emergent gravity suggests that gravity might not be a primary force like electromagnetism. Instead, it could be a phenomenon that emerges from the collective behavior of microscopic components, similar to how temperature emerges from the average energy of molecules in a gas. Think of it like the behavior of crowds at a concert. Each person acts individually, but their collective movement forms larger, emergent patterns. In this view, gravity isn't a force in the traditional sense, but an emergent property of the underlying structure of space and time. Dutch physicist Erik Verlinde introduced a new perspective on gravity in 2010, drawing inspiration from quantum mechanics and thermodynamics. Verlinde proposed that gravity is akin to entropy, the tendency for systems to move towards equilibrium. In his model, masses distort an entropy landscape, a conceptual representation of how disorder changes in the presence of mass. And the tendency of the universe to maximize entropy creates the gravitational attraction we observe. Gravity may be an illusion in the sense that it emerges from the interaction of more fundamental components, rather than being a standalone force. It's like how surface tension is not an independent force, but the result of interactions between water molecules. Similarly, gravity might be the macroscopic result of many small interactions happening at a microscopic level. The holographic principle and gravity. A key element of emergent gravity is the holographic principle, which suggests that all the information contained within a volume of space can be described by information encoded on its boundary, like a hologram. Imagine a can of soup. All the information about the soup's contents could, in theory, be represented by information on the label. Similarly, the three-dimensional space we perceive might be encoded on a two-dimensional boundary. This means that what we perceive as three-dimensional space could be a projection from a deeper, underlying reality. In emergent gravity, gravity arises from information encoded on the boundaries of space. The presence of mass and energy alters this information, leading to the emergence of gravity. Imagine a black hole. All the information about what falls into it is encoded on its event horizon. Emergent gravity extends this idea to the entire universe, suggesting that gravity is an emergent feature of how information is organized. Implications and challenges. If gravity is emergent, it could change our understanding of the universe and provide an alternative explanation to dark matter. Traditionally, dark matter is invoked to explain why galaxies rotate at speeds that, according to visible matter, should not be possible, implying the existence of unseen mass providing additional gravitational pull. To connect emergent gravity with dark matter, consider that instead of invoking invisible matter to explain galactic motion, Verlinde suggests that the way gravity emerges at large scales could account for observed discrepancies. This means that the extra gravitational pull observed in galaxies might be explained without dark matter. However, emergent gravity is still a hypothesis. General relativity, Einstein's theory of gravity, has stood the test of time in numerous experiments. Any new theory must replicate these successes and provide new predictions that can be verified. So far, emergent gravity hasn't reached the level of detail and predictive power needed to replace general relativity. Is gravity just an illusion? So, is gravity just an illusion? In the context of emergent gravity, it might be. Not an illusion in the sense that it's not real, we still feel its effects, but an illusion in the sense that it's not fundamental. Instead, gravity could be a byproduct of deeper processes involving space, time, and information. This perspective opens up fascinating possibilities. It hints that our understanding of the universe is still in its infancy, and there could be deeper layers of reality waiting to be uncovered. Perhaps gravity, dark matter, and even space-time itself are all emergent phenomena. It challenges us to question what is fundamental and what might be a complex illusion brought about by underlying processes. While emergent gravity is still developing, it captures the imagination. It reminds us that even the forces we take for granted might be hiding secrets, and the universe is far stranger than we can imagine. Our journey to understand the cosmos is far from over, and emergent gravity remains a hypothesis that encourages us to explore further, questioning what we know and searching for deeper truths about the nature of reality. What other fundamental forces or phenomena might also be emergent, waiting for us to discover their true nature?